Mitochondria are often called the powerhouses of our cells, and this isn't just a convenient metaphor. These organelles are absolutely critical for energy production, generating the ATP that fuels virtually every cellular process in your body. But here's the problem. As we age, mitochondrial function declines significantly, and this decline appears to be one of the primary drivers of the aging process itself. The mitochondrial theory of aging proposes that accumulated damage to mitochondrial DNA, combined with increased production of reactive oxygen species and declining ATP synthesis, creates a vicious cycle of cellular dysfunction. Mitochondrial DNA is particularly vulnerable to damage because it lacks the protective histones that shield nuclear DNA, and it sits right next to the electron transport chain where reactive oxygen species are generated. Now, what can we actually do about this? The research points to several actionable strategies, and I want to emphasize that these aren't speculative. They're based on studies showing real improvements in mitochondrial function. Nutritional supplementation offers one approach. Pyrroloquinoline quinone, or PQQ, has been shown to promote mitochondrial biogenesis, literally helping your body create new mitochondria. Typical dosing runs around 20 milligrams daily. Coenzyme Q10 is another critical player, serving as an electron carrier in the mitochondrial respiratory chain. Alpha-lipoic acid acts as a potent antioxidant that's both water and fat-soluble, allowing it to protect mitochondria from multiple angles. Exercise, particularly specific types, may be even more powerful than supplementation. Zone 2 cardio training, where you're working at a conversational pace for extended periods, has been shown to dramatically increase mitochondrial density and efficiency. We're talking about 45 to 60 minutes, 3 to 4 times weekly. Resistance training also promotes mitochondrial health through different mechanisms, primarily by increasing muscle mass and the metabolic demand that drives mitochondrial adaptation. Cold exposure therapy represents another fascinating intervention. When you expose your body to cold, it triggers mitochondrial uncoupling in brown adipose tissue, essentially forcing mitochondria to work harder and adapt. This can be as simple as cold showers or more structured cold plunge protocols. Intermittent fasting deserves special mention here because it triggers a process called mitophagy, where damaged mitochondria are selectively removed and recycled. This cellular housekeeping is crucial for maintaining a healthy mitochondrial population. A 16-hour daily fast or periodic longer fasts of 24 to 48 hours can activate these pathways. Here's my concern, though. People often approach this haphazardly, taking random supplements without understanding timing and combinations, or jumping into extreme fasting protocols without preparation. The research suggests that mitochondrial support works best as an integrated approach. You need the nutritional building blocks, the exercise stimulus to drive adaptation, and the fasting periods to clear out damaged mitochondria. Timing matters too. CoQ10 is fat-soluble and should be taken with meals containing fat for optimal absorption. The practical application here requires commitment and consistency over months, not weeks, to see meaningful changes in mitochondrial function.